Yeah, we are live. Hi guys, how are you? We came back to online after a little pause, but I hope you are doing very well throughout the year and you are safe throughout the two waves of pandemic. Okay, today we are going to have a tech talk from Josh Long. Josh Long, he's a Java champion and he's a developer advocate since 2010. He authored many books such as Reactive Spring and designing resilient systems with Spring framework, such kind of things. And he also authored best-selling tutorials on Spring framework. And Yeah. So today our topic is on using Kotlin and Spring Boot in the backend development. Our topic name is Bootiful Kotlin. So guys, if you have any question, please feel free to comment them in the comment section. We will make sure that those will be addressed by Josh while the talk is going on. Yeah, Josh, stage is yours. Please start the talk.
Very good. Thank you so very much. Hello, everybody. How are you? I am sharing my screen here. Let me see if you can. I think we should all be on the same browser page at this point. let me know if you don't see the screen there. Okay.
Yeah.
Okay. Good. Thank you. All right. Good stuff. Thank you so much, everybody, for joining us today. I wish I could be there in person. It has been a rough 2 years, hasn't it? It has not been very good for networking, right? Which is, as computer people, where we work on distributed systems and networks, it's a little bit ironic that we can't network so easily, but I hope one day I'll be able to return to you all and get some delicious biryani and so on, and hang out with y'all. But anyway, I'm very happy to be with you right now. And I'm hoping next year, I would love to see you all next year. I had the vaccine, I had the virus, you don't want the virus, don't get the virus, and I got a booster. So if it's scientifically possible to safely travel from one place on the planet to another, at this point, I think I can do it, right? Like, if I can't do it, then it can't be done because I've got all the antibodies. So I hope next year we will be able to meet. Who knows, maybe next year's too early. Who knows what'll happen, but I hope. Anyway, I'm very happy that we get to be here online together, obviously, and it's fine. We can hang out more. We have a lot of time to hang out here, and we can. One of the nice things about being online is that we're probably in our homes or in some place where we're just comfortable, and we don't have to sit in hard chairs in the middle of a venue somewhere. You have access to your kitchen and to your toilets and all that stuff, so you can get food, and maybe it's more comfortable. Maybe this is better. Who knows? A lot of reasons to be happy. But anyway, my name is Josh Long. I work on the Spring team, as was just well explained. I've been on the Spring team as the first Spring developer advocate since 2010. I'm a Java champion, and I'm a Kotlin Google developer expert, which is, I think, particularly apropos given tonight's discussion. And we're going to talk about a lot of stuff, and that stuff I keep on GitHub as I do everything else. I didn't realize this, but I was kind of rifling through all my my GitHub repositories and stuff, and there's a lot of I have a mess. It's quite a mess. My GitHub repository, my GitHub profile. There's like 500 more than 500 repositories, and dozens of organizations and all that. And yeah, if you're not careful, you can easily make a lot of code. Most of it is just like not very great. It's not very great, but it's just a lot of code. And so, anyway, if you're on GitHub, please follow me there. I didn't realize that was a thing you could do, but apparently people follow me on GitHub, and there's like 7,000 of them, which what's that about? But anyway, I'm on Twitter, which is definitely easier to find. If you're on Twitter, find me there at StarbucksMan. If you're on LinkedIn, I'm there. If you want to talk via email, I'm happy to engage there, josh@joshline.com. I have a podcast that comes out every Thursday, California time. So that would be easily, later in the afternoon or evening for you there in beautiful India. And of course, I have a YouTube series where I have a new video. I just finished editing that video this afternoon. So that'll be up it's every Wednesday. There's a YouTube video. This one, it hasn't come out yet, but I'll tell you what it's about. It's about WebSockets. And then I've got a Twitch stream where I occasionally just write code, I don't know. Don't get your hopes. I mean, I hope that what we do on the stream is fun, but a lot of times it's just me doing boring stuff and I want company. So for example, the last few days I've been editing CSS and I keep thinking, well, maybe I should start streaming that, but I was like, CSS, cascading style sheets. I don't know if I don't think that would be a lot of fun. I don't know if people would join me for that. It's very, especially if they're coming at me like expecting JVM discussions and all that. And then I've got a blog, and if you want it's not a great blog, don't get me wrong, but if you want a rundown of all the new stuff as it's happening, it all appears there automatically. So blogs and appearances and YouTube videos and podcasts, all that, they get updated, and you see new entries automatically syndicate there in the blog. and you'll have to forgive me, please. I've got something dry. Just 20 minutes ago, I had a meeting with some folks in Germany before I joined you here, and my throat just went hoarse right in the middle of it. I don't know what all is going on. I've got a big bottle of water, but you might see me sneaking away to refill it as we're talking. Okay, so my friends, we're going to talk about Kotlin and Spring. Obviously, if you're in the Kotlin ecosystem, you probably already have some sense of the possibilities here. There are two major camps in the JVM ecosystem. There are two major schisms, if you will, that I like to think about it. We have client side and we have server side, right? And obviously, Kotlin has a very strong foothold in both of these. Certainly more so in the client side where we have Android, right? But definitely also fairly, very strong in the server side as well. By any objective measure, Kotlin is now the second most used language on the JVM. So Java proper, which is of course not a monolith, right? Java is any version of Java from 6 onward, and we're at Java 17 right now. The JRE, the JVM, the JDK, that's all Java 17. So, we have 11 versions of Java in spread across that range, really. And so when we talk about that, it's not really fair to say just Java, but that's what we do. We just say Java, and then we have Kotlin, and Kotlin, of course, is, it's fairly consistent, right? It's also much newer, so the spread isn't nearly as big. But yeah, Kotlin, by any objective measure, is the number 2 most prolific, most widely used language, and for good reason. It's become so popular in the client-side community because it's pragmatic, and likewise, it's become so popular in the server-side community and the Spring ecosystem because it's pragmatic, and that is a reflection of the team, not the technology. I mean, the technology is pragmatic to the extent that the technology can be anything, but it is so because of the team that works on it. And that's, I think, what drew me to it, right? I first started using Kotlin back in 2016, and I was trying to wrap my head around some of the use cases, and was it just a better Java or was it something else entirely? And if I'm honest, I didn't really know what to think of it because I was looking at Scala, and Scala seemed like a complete paradigm shift. And if you're going to learn language, might as well go big, learn an ecosystem, learn a new way of thinking. And Kotlin didn't really seem to have a strong opinion about that. It just seemed like it was a really nice, convenient, clean way to do something on the JVM. It wasn't different per se. It wasn't, or at least it wasn't different. There was no paradigm implied. If you knew Java, then you already knew conceptually what you were getting when you use Kotlin. You could forget some of the warts of Java, but it was still basically the same game. And at some point I realized, that's actually a big deal. This language wants to be what we want Java to be, but it wants to be that for, different communities, and it wants to do it now, as opposed to, on the business end of a JDK iteration cycle, which can be years and years and years in the making, right? It takes forever to get things added to that. So that pragmatism is its biggest feature to me. That is a huge deal. And I'm not alone, obviously. I mean, you're here, right? And I remember I got invited to speak at the very first Kotlin Conf here in sunny San Francisco, California, in the United States, back in 2017. They invited me in 2016. And I'm thinking, well, gosh, because this is, at this point, I was traveling around the world, doing whatever it is I used to do before the pandemic, 650,000 miles or 1 million kilometers a year, every year, right? So I got around, and I was like, oh, somebody wants me to come to San Francisco, where I live, and give a presentation. I said, I'll be there. Thank you, Hadi, for the very kind invitation. You're a good friend, and I cannot wait to see my own bed, while I'm there. So I was just grateful for all sorts of reasons. Even if the conference ended up just being me and 30 people or whatever, I didn't care. I was very happy to do it. It meant I got to go home. I get there and there's like 1,000 people. It was the first conference and there was 1,000 people. It's huge. And this conference had no advertising. There was no marketing that I can remember. It wasn't like a big deal. It was just sort of this word of mouth thing. People are like, oh, we're gonna have a Kotlin conference. Of course we are. Why wouldn't we? It's gonna be huge. And it was. There's this huge outpouring. And remember, this is before Google supported Kotlin officially. And this is well before Google endorsed or made the first class choice in 2018, the Kotlin programming language, right? So all of that was on the strength of just people were digging it. They liked it, right? Anyway, I'm a big fan. So that changed my mind. When I saw that, I was like, oh, this really is something. It's awesome. It's pragmatic, and that's in of itself very useful. So around the same time in 2016, we on the Spring team started supporting Kotlin on the Spring Initializer. Now, the Spring Initializer is startup.spring.io. We're going to be looking at that, of course, in the next whatever odd minutes we have together. But we allowed you to build Spring applications using Kotlin, as we do for Groovy as well, right? So it's just another choice because these are all languages that support objects and annotations and methods and the usual suspects that are required to support a framework that uses those things like Spring. And so I was expecting, in that already, it was kind of a nice experience. You could already use it, but the real sort of turning point came for at least for me in 2017 when we released Spring Framework 5. Spring Framework 5 introduced native Kotlin code, actual Kotlin code into the Spring Framework codebase. Yes, that codebase, the Spring Framework codebase, the one that's been around in some form since 2001, right? That codebase that has grown and very rarely had to be changed because usually when they add to it, they do it with such contemplation that there's very little reason to break things backwards incompatibly. Hence, and so the idea to me that there could be code in there that is written in Kotlin that has to be maintained in Kotlin and that cannot be changed back to Java because we do a very good job of backwards compatibility. That was a huge ringing endorsement of the language, right? That exercise was all about adding functionality to Spring to make the APIs more idiomatic for the average Spring user working in Kotlin. And I just thought, oh, that's great, right? I mean, same great Spring flavor, but half the fat, right? It's just you're not paying for all that all those extra lines of verbose Java code. I loved it, right? I was just so excited when we started actually we shipped Kotlin. It wasn't even a separate library. As you know, it's easy to create extension functions, but no, we could have shipped those as a separate jar, and that could have been like the Spring Kotlin project, but nope. We put it in Spring Framework itself, in the jar itself that everybody using Java downloads. And so huge deal, right? Now suddenly it's a first-class citizen. Now you can build applications that take advantage of this. And I think our ecosystem, the Spring projects, the Spring maintainers, the leads of all these different projects, there was no, I can tell you, I'm on the inside, right? I can tell you that there was no big, and this does happen on occasion, right? On occasion, there's a theme. We talk about themes on the Spring team. We talk about things that we want to unify around, right? So for example, reactive programming is a big deal. And we all said, okay, let's make sure that the story for reactive programming is consistent across all the different Spring projects so that somebody wanting to build an application would not find an inconsistent experience across the different projects. Were they to look for a reactive experience and were it to make sense to have it, it should work and feel similar, right? So that's a theme, and we all kind of converged upon that. But there was some upfront sort of thinking here. With Kotlin, it was just very much we started in small amounts, and then just people naturally gravitated to it because all these different project leads like Kotlin. They liked the DSLs they were able to build for their different projects to make it more natural, to make it more accessible. And so it just happened. People just liked it. Nobody had to There's no prompt. There's no like, let's do this, team. Let's get on this. It's just sort of, I want to do this. How are you doing it? I'll do it the same way. And so that was that kind of sort of going through the motions. I thought was just super, super interesting, right? Because it was a very spontaneous, organic embrace of this language, which again, we have. You've seen our GitHub issues, maybe we have a backlog of things. Like, it's not like we have just ample free time to just do whatever we want. But nope, we found time to make these DSLs. And so now today, you'll find as we talk about it today, there's a lot of different libraries that have Kotlin DSLs. So my friends, we're going to use some of that, right? We're going to look at some of that stuff, and we're going to do that keeping in mind that, again, it's the pragmatism that makes this language so ubiquitous, so successful. You can use Kotlin to build Android applications. You can build it. You can use Kotlin as a better JavaScript with Kotlin JS. You can use Kotlin as a better Go or C with Kotlin native. You can use Kotlin as a better Java with Kotlin on the JVM. Did you know that there was a sort of a wayward attempt at Kotlin on the .NET platform? I don't even know if that's still happening or what, but there was. That was a thing I remember happening. So, Kotlin is just really interesting. It wants to be where you are. It wants to make it easy to build and solve problems in the space that you're working. It meets the developers where they are, which is super interesting. And that's why you have these huge companies like Pinterest and Coursera and Netflix and Uber and Square and Trello and Duolingo and Basecamp and Dripstat and Corda and all these different companies all using Kotlin at scale in production, which is huge deal, right? Is DoorDash? Did I make that up? It might be. I think DoorDash does, but I'm not sure. There's one company here in the Bay Area, I think it's DoorDash, but again, I could be wrong, that uses Spring and Kotlin, right, as well. There's I'm sure others do as well, but that's one that I was just very enamored of. Okay. So with that backdrop established, let's get to it. We're going to go ahead and build some software here on my second favorite place on the internet. My first favorite place on the internet, of course, as always, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you begin your journey here at start.spring.io. What we're going to do is we're going to build a new service, choosing Kotlin as our language, and then choosing the name of the artifact, right? And I'm going to just choose customers, and we're going to use some just boring stuff that you've no doubt seen before, because in this first section of our discussion, I want to kind of like look at ways that just Kotlin, the language, makes ecosystem integrations and libraries that have been around for decades more palatable. It just makes it, it's just a fresh coat of paint on stuff that was already fine. It wasn't like it's an issue. It's stock standard, tried and true stuff that just gets that much easier and more approachable for its integration with Kotlin. And then we're going to look at in this first section, we're also going to look at how by using Kotlin, you are opening a door into a nice community, right? It's Kotlin isn't just a great way to consume old stuff from the JVM, from the Java ecosystem. It's a great way to open up the doors to all the stuff that's unique to the Kotlin ecosystem. And so we're going to look at that in our first section here. So to kind of make that point, we're going to just use some basic stuff, very trivial, very mundane sort of stuff. We're going to use a SQL database using JDBC. We're going to use the JDBC support. We're going to use the web service support using Apache Tomcat. And, I think that's it. We have here the choices of what version we'd like to use. For us, it doesn't all that much matter what we use, but obviously for a runtime, the choice is clear. You should be using Java 17, right? Or in a pinch, if you're going to be using Spring Native, right, which is our GraalVM native image support, then, for all intents and purposes, practically speaking, that means Java using GraalVM 11, even though they just released a 17.0 compatible version, I think last week or 2 weeks ago. I'm sure that the Spring Native support for 17 will arrive sooner rather than later, but in the meantime, that effectively means Java 11. But for everybody else, we've only got one choice, right? Only one choice, one real choice, which is the current long-term supported version of Java. Obviously, the last long-term supported version of Java is Java 11. And the wrong version of Java that you could use that's not appropriate to be used is Java 8. Java 8 is slow, creakingly old, long since past its prime, irrelevant in every way, less performant, less secure, less robust, less operations friendly, and just a terrible choice in every way, right? It's technically inferior in every way to Java 17. In fact, if you judge by the number of versions, then 17 being 2x8 plus 1 is at least twice as good as Java 8, right? By that very silly logic. So I encourage you to use Java 17 for your runtime. Obviously, for our purposes, we're not using the syntax of Java. We don't care. So we can compile down to whatever Kotlin supports. And this is nice about Kotlin. This is the nice thing about Kotlin. We can use features and syntax that feel like they're Java 25, and yet they compile down to Java 8, you know? Okay, so let's see here. Downloads. I've got a zip file here. I'm going to open this up. I have a little script, a little alias in my operating system called UAO, which means unzip and open. It's going to unzip my zip archive and then run idea space and then the pom.xml in that archive. And that's going to open up my IntelliJ IDEA IDE, which I will use to write some code with you today. Okay. All right, first things first, we've got our pom.xml, and this is the one thing. This is the first thing I love about our integration with Spring and Kotlin, right? So we're using the regular stock standard Spring Boot. Nothing special about this, but we've specified what version of JVM and what version of the Kotlin that we're using. Obviously, on the, like I say, on the runtime side, I'm using Java 17 because it's the right choice, right? But in terms of the syntax, all of that is just par for the course. I'll just leave that as is. But when we generate a new project using Kotlin as a checkbox, we automatically get the appropriate modules to support its use in the Spring ecosystem. So you don't have to bootstrap a project manually anymore. You can just go to start.spring.io. We also configure the Kotlin Maven plugin, and we configure the Kotlin all open Maven plugin as well. This all open Maven plugin is another example of where the Kotlin team has a lot of pragmatism. You see, we went to them and we said, look, there are some while the default in Kotlin is for types to be final, to be sealed, it doesn't make a lot of sense in the context of a framework like Spring where we need to subclass those types. And if they're effectively final, that means that the user, for every instance of a component that needs to be, that interacts with the framework, every single type will have to be open space class space my class, right? As opposed to just class my class, which is what we get in Scala or Java. And so they created a plugin, and this plugin is just very pragmatic. It says, okay, well, the framework author can prescribe certain criteria, through which we decide that these types will be automatically opened by default as opposed to closed or sealed by default. And this plugin is just an example of where they wanted to make this the best experience for people using Spring. They just were very happy to make that happen, and other ecosystems where that applied. And so within that, kind of plugin, mechanism, there's a particular integration for Spring, and it just works. You don't have to worry about it. Don't have to know about it. But if you are used to writing Kotlin, you might be surprised to find you don't have to write open for everything now, because we just take care of that for you in the build, thanks to the wonderful Kotlin team. And that work, by the way, the work of providing the integration was months. It was months to get it right, as opposed to half a decade, like some other ecosystems out there. Okay, all right. So we're going to build an application. Our application is just going to be a stock standard JDBC application. So we're going to create a class, and of course, this could be a Java-like class. We could create a val ID int and make it a null or something like that. We could, but obviously the right thing to do, since this is more than likely just going to be a dumb struct, is to just create a data class, right? So we're going to create a data class. We're going to say val ID int val name string. All right, there's our basic data class, and this of course has getters, setters. Sorry, it doesn't have setters. It has getters, and it has storage, fields in the class for these constructor parameters. If I wanted to not have getters, to not have those properties accessible from the outside, you probably know I could just add private there. And then next, I want to define an interface that I'll use to define, to surface or to formalize the contract of the thing that allows me to talk to my repository full of this data of type customer. So given a call to the function, The member function called all, I expect a collection of customers. Now, we need to actually, we need to actually have data in the database, don't we? So let's go ahead and add a couple of files here. First, schema.sql. We're going to say create table customer ID serial primary key name varchar. Okay. 255 not null. Voila. Okay, there's this. And then over here, we also want to create a new file called data.sql. So these two files, schema.sql and data.sql, will be executed in that order when the application starts up. It's a great way to bootstrap. In this case, I'm using H2. H2 is an in-memory SQL data store, so it doesn't connect to another repository. By the way, keep that in mind. When I start up my application, I'm starting up my web server. I'm starting up my connection pool, my database data source connection pool, talking to the database. But I'm also starting up a whole SQL 99 compliant database. Okay, so that'll slow things down, of course. Okay, insert into customer name values, and I'm just going to put some people that who, let me think about it. They're just nice people, wonderful people, some of whom are in the Spring team. Mala, Dr. Subramaniam, some of my heroes, of course. Inaya on the Spring team. Madura on the Spring team, also heroes. Who else is on the Spring team? I'm on the Spring team. I count. There we go. Spence, Olga. There we go. So Stefan. Yo. There we are. Good. So there's 8 names. Okay. So now we should be able to create an implementation of this interface. And again, stock standard, if you've used Kotlin before, you're probably on the same page here, but it's just regular imports. This is a standalone top level class. This is a type. There's no relationship between this type and this standalone member function. Here, if you've ever used Spring Boot before from Java, then you'll recognize that this is slightly different. We're not actually using Spring application.run as you would normally do, right? We're actually using a function which uses pseudo reified generics called run application. And the reason we're doing this is because it's just cleaner. Look at that. We don't have to specify a type token. We don't have to capture customer's application.class and then pass that as the first parameter to Spring application.run. We have this nice Kotlin integration in Spring Boot, right? That just feels natural. And this is an extension function, right? Very, very powerful. So do I want to accept it? Yes, I do. Of course I do. Good stuff. So look at that. So it's just a function. It takes the var argument string. It takes a type of T, but you see it says inline reified. So basically it's going to capture that type at compile time and then create a little token, and then it'll make it look like that was captured at call site time. Okay, so I'm going to create a class here that implements that. We're going to call this JDBC customer service because I have a very good imagination for names. And no, I don't. I'm just kidding. That's a terrible name, but it's fine, right? We're going to use the Jdbc template, which is something you might be familiar with if you ever used Spring. It's a type that just makes working with SQL data stores easier, right? SQL is an awesome language, and if all you want is just to talk to a SQL data store, and you don't need or feel particularly inclined to bring a whole SQL ORM into the mix, then don't. Just use Jdbc template. It's easy. It makes Jdbc very approachable. So very simple, right? Select all from customer. Very trivial. This is what you would do any day of the week and twice on Sundays, right? So the thing is, it's going to run that query, and then I want to turn the results into data that I can work with, right? So data mapper, customer, and basically I'm going to provide a row mapper, and this row mapper is going to be given a pointer to a result set and an index. But the thing is, I'm not going to use the index, so I'll just use underscore, and I'm going to turn each result set, as the query is executed, as the method.query executes, it's going to visit each row in the result set, and it's going to call back my row mapper, and it's going to say, here's the current result set with the current offset, which is the index, the offset from the delta of the origin of the of the record. So it's going to say, okay, here, do whatever you want with this type. And I'm going to say, great, I want to create a custom out of it given the current ID and given the name. Okay, so that's pretty simple. I mean, you've seen this before. There's not a lot of magic here. So this is a inline interface inside of a function in Kotlin. Now, of course, can we clean this up? Well, of course. First things first, you don't need this. This is redundant. It used to be required before in Kotlin, but now it's gotten cleaner. The IDE is telling us, hey, look, if you have a function in Kotlin where the only arguments are a lambda or the last argument is a lambda, it can be outside of the parentheses, right? Like that. It can just hang out like a block in Ruby. And so that gives us a very simple way to query all the records. So let's create a simple controller, a REST controller to read that data, shall we? So we're going to create a REST controller. We'll say at response body customer REST controller. I'm going to inject my JDBC, my CS. There you go. Say customer service, and we'll say at get mapping customers fun customers, and we'll say equals this dot cs dot all. Okay, just as simple as it gets. A very simple HTTP controller that reads all the data and just dumps it out to the client. Okay, here we go. Let me make this a little bit bigger. Localhost customers. There we are. There's our records. We happy few. It worked. Of course, it worked. So good stuff, right? We've got a very simple Jdbc template, and this Jdbc template is one of the first types that was in Spring. If you know about Spring, then you know that it's been around for a long time, and this Jdbc template is one of the things that I remember pulling into my other projects that weren't Spring based, just to get use of that, because it made my life better, even if I didn't yet have the permission or the scope to bring in all of Spring and to use it for the whole application. Back then, you really had to like shoehorn your stack together, right? And this is very much in that era of like, okay, I've got some golf game that was played, and so I have to use EJBs, but like I want to make my data access logic as simple and trivial as possible. So I'll pull in Spring's JDBC template. And so this has been around for, nigh on 20 years now. It's awesome. I use it all the time, even today. That said, it's still very much a, Java API. It's literally the Java database connectivity API. Can we do better? Well, surely, right? There's a great way to talk to SQL data stores in the Kotlin ecosystem called exposed. And so what I'm going to do is I'm going to go back to my build and bring in the new exposed dependency, the Spring Boot starter for this exposed ORM. Okay. Okay. So actually, before we do that, before I get too far down that path, let me just make sure we're clear about something. I used this function here. I said select all from customer, and this is just regular. I'm using the Java API. But what if I had a parameter? What if I wanted to say where ID equals question mark, right? Well, of course, this is a parameter, and normally in the Java API and the JVM API, you would have the row mapper here, right? You'd have a row mapper as the second parameter, and then you'd have the parameters that get fed into the prepared statement as the positional parameters. Those are the third argument, the third set of arguments. And the reason for that is because in Java, if you have a variadic array of arguments, that must be the last position parameter in the function, in the method definition, right, in the prototype. And that makes sense. Obviously, the compiler can't, if you've got like n arguments, it doesn't know whether, it just doesn't know. So you have to the fixed positional arguments are the first ones, and then you have the variadic array. Okay, makes sense, obviously, but it's ugly. Look at this. This is hideous, right? So what I want is to have the arguments because I want my lambda to hang outside my function invocation, don't I? Like a block. And so again, let's say I did this now. Let's say I did what I wanted to do here. Clean that up. Look at that. There's an extension function that comes in from Spring that makes that happen. And all this extension function does is it adapts the Java API. It just literally reworks the arguments. It doesn't do anything in particular or anything special. So it's a query, takes a string, it accepts the variadic array of arguments, and then it takes a function. And that function, is our functional interface, which we were defining before, is also a function in this case. Because Kotlin has first class support for functions. So it just works out, right? It just knows that this is the argument array, and the last argument must be the lambda, and therefore just use that, right? So this is an example where Spring, it's still Spring. We haven't changed anything. It's just that by using extension functions, the Spring team is able to adapt APIs that have been around for 20 years in a still completely backwards compatible way to accommodate these new use cases, which I think is marvelous, right? A lot of foresight with the use of extension functions here. And the nice thing about this is that because you have to opt into it, it's explicit here. You get to see what's happening. It's not like monkey patching in Ruby where you can just define a change on a type in some other class in the code base, and that changes the behavior for every other type or every other use of it anywhere in the same Ruby virtual machine, which can be baffling, you know. Okay, so we have our customer types. We have our records. Now, like I said, I want to change the mechanism for persistence. So I'm going to create a new service here called exposed customer service. And exposed is an ORM from the good folks over at JetBrains, right? And it's awesome. It's just a nice, simple, type-centric way to work with SQL data store, but it's still SQL. You're not like adding a full-on ORM layer. It's just a very nice way to build queries and work with data stores. And I quite like it. So let's implement customer service. In terms of that, we'll just implement this. Very good, no problem. And finally, with that done, we'll say private val. Well, actually, we don't need to say anything. We just need to use the definitions here. So we need to create a table. We need to create metadata to describe how to map our SQL data to an object, right? And so the way you do that is with a type that has the mapping, but that type is only ever used once, right? Well, so why would you create a class? So what you do is you create a Kotlin object. And so this object is going to extend table, which we don't have in the class path just yet because I have yet to bring in the dependency. So I'll say, give me exposed Spring Boot starter. Okay, there's that. So that's one of the more recent versions. I don't know if it's the most recent, but it's fine. And table. And so I'm going to say, give me the exposed table here. And we're going to just going to describe our metadata, right? In terms of this this object. So let's see here. It's customer, I think. Yeah, customer. Good. So customer. And we're going to have an ID field, which is the primary key. So ID equals integer ID dot auto increment because it's a primary key. We'll have another field here called name, which is the, well, you know, it's the name, right? It's a string with 255 character length. And that's it. That's my metadata mapping. And with that, I can use it to actually run queries in my exposed customer service. And there's nothing to inject. There's no instance because it's just a static, you know, object. It's a single. It's a singleton, if you will. Okay, so I'm going to say customers dot select all dot map, and what I get is I'm given a pointer to something called a row map, and I want to use that row map to create customer objects. So I'll say rm customer dot id rm. Oops, I forgot to be explicit. Let's just use it. Okay, so customers dot name, and voila, there's my identical implementation. It's doing exactly what I did before, except there's no strings involved except in the definition of this object. And if I did something wrong there, it's very easy to identify it and fix it. So let's go ahead and I've commented this other one out. So when I inject the implementation of customer service, what they'll get is this version. You also want this to participate in a transaction, and the exposed project has a very lovely Spring Boot starter that makes it accessible from within the Spring ecosystem. It's super accessible anyway, but the Spring Boot starter handles even more of the work for you. So it just makes it just drop in simple, as you've just seen. The one thing you need to keep in mind is that exposed expects to run within a transaction, even if you're just reading data, right? And so you need to start a transaction. That's fine. There's an abstraction in the Spring ecosystem called the Platform Transaction Manager. And that implementation, that type, is a way of demarcating when work starts, when you commit with the work, and when, if for whatever reason something goes wrong, you roll back the commit, okay? And that Platform Transaction Manager abstraction is myriad. You know, there's a lot of different implementations that you can use. Here, the implementation that we want is something that is aware of the life cycle of the data of the resource transaction for exposed sessions, right? So they provide one. They provide an implementation, and it's already been auto-configured for us. The only thing we need to do is to opt into it by saying add transactional, and we could do this on a per method basis, or just you can say every method in my service is going to be transactional. That is to say, well, it'll be enclosed in the scope of a transaction. In this case, it's read only, so shouldn't matter that much. Okay. Restart. Okay, there's our application. It's up and running. And there we go. There's the same data, but this time it's coming from exposed, right? So again, have you learned about anything new here? No, probably not, right? Hopefully not. I mean, maybe exposed, or maybe some of the extension functions. But my point is, it's not like you didn't know how to talk to a SQL database before, or to build a simple HTTP endpoint. This is not necessarily about leaps and bounds and paradigm shifts. It's just, the expression, it's a death by 1,000 cuts. If there is such a thing as a death by 1,000 cuts, then surely there's new life when you have 1,000 healing keystrokes, right? Like 1,000 healing features of the language. This does that. This is for every cut that gets you in some other languages. This one just seems to just want to get out of your way, and it just makes it easier. And if you get enough of those, it just starts to change how you feel on a day-to-day basis. It's all about joy, I guess. Okay, so we have a very simple SQL API. Well,
Josh, sorry to interrupt. There are some questions on the language.
Queue those up?
Yep.
Or actually, you know what? Actually, now's a good time. Let's time box it though, because we have a lot more to cover. But yeah, go ahead and hit me with those questions, and we'll move on.
Okay, there is one question from Neerja. I use Java for Android development. How do I practice Kotlin so that I actually take the advantage of language rather than just writing some statements I did in Java in Kotlin?
Well, in Android, or just in Spring, or what? Like, because again,
I think she is trying to learn Kotlin. So
yeah,
she's writing the same statement. What she is feeling is she's writing the same code whatever she is doing in the Java, and she want to practice it so that it can be in Kotlin style.
Oh, that's actually okay. So remember earlier I said that Kotlin doesn't really come at you with a very strong opinion about things. That's not quite true. What I was trying to say was, it's not a completely different paradigm shift. That said, there are some opinions, and those opinions, if you can find ways to write code that lines up with those opinions, you will find that your life is better when you write Kotlin. And so one of the things that takes a little bit of time for people to get used to when they write Kotlin is to embrace the idea that you're going to be final, or your state is going to be, if not immutable, it's going to at least be hard to change, right? It's going to be read only as much as possible. And so you can see that when, like, for example, when you try and create a field of type var, the IDE highlights it with some dreadful underline here saying you've just done something weird. It's okay, we're not going to stop the build, but you should know. And if anybody sees this, they're going to know what you did. It's going to be, they're going to talk about you and maybe snicker at you in the water cooler, right? So they want you to use val. Val feels more natural. And you might say, well, gosh, I have a lot of, decisions to make. I have a lot of things I need to figure out before I can assign the result to the immutable field. So surely I'll just end up with a few important final result state val fields, and I'll have a bevy of intermediate var fields that are used to store the results of the computations that then get assigned to the val. And I can understand what you're saying. In Kotlin, it's really easy to avoid those intermediate types, those intermediate fields. So for example, if I have a name here, yeah? So this is my name, right? Let's say Josh. And I want to change this. Well, Kotlin has, I could say I want to create a new, name upper. I could say name to uppercase or whatever, right? And this is, why is it unhappy? I don't even know. Doesn't matter. It's unhappy, but it'll just have to live. And then maybe I want to do something with that. Well, I don't have to have intermediate variables here, right? In this case, I probably didn't even need to have uppercase intermediate variables either. But let's just take a simple example. Let's suppose you have sequence of state transformations that you need to account for before you can store the resulting variable. And this is very common, but because the Kotlin makes it so easy to work with expressions, you can actually create a variable, let's say Josh, and I can say that I want to do something with that. So I can say let, right? And what this will do is, given a type of string, which is the string it, which is Josh in this case, given that, I'll say to uppercase, right? And you could do this even if the thing that was coming before didn't return, even if it didn't produce it itself, right? So here I'm doing an uppercase, and then maybe I want to do another let or whatever. So I can actually end up doing work on this type all without ever having to store it in an intermediate sort of variable. So the result is that I have a number of transformations that are expressions that result in the final value that gets stored into this field, which is not so easy to do in Java. And another example that they just fixed in Java, but that wasn't fixed until recently, is expressions in Java used to be just a statement. You had to do the switch expression. Sorry, switch expressions used to be just a statement, or switch blocks used to be a statement. Now it's possible to create a switch, expression wherein you can say assign the outcome of a switch to a variable, right? In Kotlin, you've always had the ability to do this, right? So you can actually have you can say val result equals, and then do a switch and have a number of different cases. And if there's a result that's decided upon, that's what is assigned to the variable. So you don't have to store intermediate variables and then handle the fall throughs and the breaking and all that stuff. It just works very naturally. So things like .let, things like .apply, right? Apply, you're able to work with the type. So here, if I do this this is the reference to this inside of whenever I use .apply, what it's doing is it's saying, we're going to give you a reference to us, to it. So I'm going to give you I'm going to reset the pointer to this to be equal to the contents of the string. So I can actually act on the variable itself as though I'm inside of that variable, inside of the type for that variable. So again, lots of ways to work on data without ever having to assign an intermediate variable. So you can have val, you can just chain these things together and do all sorts of, let, apply, that kind of stuff. So I think that's one thing I would keep in mind. The other is if you find yourself doing, not using expressions, that would be weird. If you're not using val, that would be weird. I would just look for ways to do that. And it's just, if you see a bunch of lines in a function, for me, I try and write as much of my code in such a way that I just do this syntax. I use fun customers equals and then an expression, right? If Kotlin doesn't care. It doesn't care if you do this, right? It's perfectly valid. You can actually create a function and just be very Java-esque about it, if you like, right? This.cs.all. That's perfectly valid Kotlin, but look how much more verbose it is. I have to tell the compiler that this function returns a collection of customer, which it already knows because there's only one expression, there's only one thing happening in it, and I have a return statement and curly braces and all that. So just find ways to work with expressions, and then Kotlin will rise up to greet you. It wants you to do that. It'll make it easier. Does that help? I hope that helps.
Yes, Josh. Very good explanation about that. And there is another question. How does extension functions work in Kotlin?
So extension functions are you just define them on a type. So they're functions where the type is specified. The receiver of the function is specified outside of the body of the receiver. So fun string dot hello, right? String whatever. Okay, so return hello. Okay, or like I said, you can just do this, right? So I've defined an extension function for all instances of strings. So if I go, but only assuming I have this imported. So again, if I don't have this type invisibility or this module, this package, whatever, then I can't use it, right? Okay, but so as an example, I can say val, whatever, whatever dot hello, val, or just print line hello, that kind of thing. You can just add functions to existing types in the code base without actually recompiling the type itself. So I don't have to I don't have to send a pull request to the JDK, to the official GitHub repository for the JDK to add that function to Java lang string, because I don't need to. I can just add it here. I can override the defaults. And this is great for library maintainers like the Spring team, where we want to provide our existing APIs, but add, new functionality.
So, Josh, while the extension functions are getting compiled, is the compiler opening up the class and putting the methods inside the class while generating the bytecode, or how it will be that?
I don't know. That's a great question. I think there's some extra dispatch table probably, but I have no idea. That's a great question. It'd be interesting to kind of look at it, because I don't really know what it looks like if I were to call one of these extension functions. I don't think you can, actually. I don't even know what that looks like. I think of it kind of like a video game, where when you use extension functions in Kotlin, your IDE will automatically prompt you with intelligent sort of auto completions that include these extension functions. But it doesn't happen when you're doing Java, even if you've got Kotlin code on the class path, right? So it's like playing a video game wherein you found a secret level. I don't know if you can do it the other way around. I don't know what it looks like from the Java perspective. I don't think Java can see it, is my point. I think it's only the Kotlin compiler knows where to look.
Okay, that's cool. Okay, as of now, we have these questions. We'll go
Very good.
to the next topic. Yeah.
Okay, let's go, because we have a lot more to cover. So we have a basic service, okay, very trivial. Customers API, I'm using JDBC. This is fine, right? Next, I want to build another microservice, but this time I want my microservice to use RSocket, okay? It could use anything actually, but let's just use, we're going to go here and we're going to use a reactive protocol called RSocket. We're going to build a new microservice called profiles. I'm going to use Kotlin again, and I'll use RSocket. Now, RSocket is a binary protocol that supports reactive programming, okay? There's not much about this particular module that we're going to build that has to do with Kotlin, but what you need to understand is that there's this concept of reactive programming in the Java ecosystem. Reactive programming gives us three big benefits. It gives us better efficiency with our resources, namely our threads. That's true for the moment. It will always be true, but in the future, hopefully, knock on wood, not too far from now, we'll also have Project Loom, which will be a suitable way to more cheaply take advantage of threads, right? That's one benefit. It'll then give us, it still gives us two other benefits besides, one of which is ease of composition. So what reactive programming does is it gives you a single type, and that type allows you to define pipelines. These pipelines are the state-by-state transitions of streams of data, right? The mutations of streams of data. And you work with pipelines all the time. If you've ever used the Java 8 Streams API, then you're probably used to thinking kind of like you're working with reactive types. You've got map and flat map or whatever. If you've ever done any functional programming, this will feel very natural as well. So you have just sort of a deterministic, you have like a very simple way to define mutations on state, pipelines of data, streams of data. And because you have a single type and you're using the API to, in a fluid DSL style, describe how data goes from state 1 to state 2 to state 3 to state 4, because that's all done in terms of the API can then run those different state transitions whenever it wants to and whenever it can, as opposed to when they would be executed in sort of lexical source code order otherwise. And this is very interesting because that indirection means that you define a pipeline, but the pipeline doesn't get turned on until you turn on the water, right? And so the scheduler, the runtime, can actually do that work for you. By the way, can you still hear me? My headset sound weird.
Hey, Josh. Yeah, we can hear
good.
you.
Thank you. Sorry about that. So it'll give you it'll allow you to define these state transitions in a way that the scheduler can then do the work of moving your different state transitions onto the right thread when there is a thread available. And that means that the corollary is true as well. It can get off of those threads when there's no need to be on those threads. And so, for example, let's say you ask for bytes from an asynchronous IO sort of based IO driver, like you're reading bytes of data from a socket, a network socket. Okay, you don't know when the next byte's going to arrive. It might arrive a week from now. the downstream thing that's sending me that data might not be available anymore. You don't know. So it makes no sense to sit there on the thread, just waiting. So instead you want to say, okay, when these bytes of data get here, then involve me and I'll work on processing the data. But in the meantime, there's no need for me to sit here on this thread because other things in the system can reuse these threads. Threads are expensive. So reactive programming gives me an API wherein I can define my pipelines in such a way that the scheduler can schedule me on threads when there's something to be done and take me off threads when there's nothing to be done. And it can then do a much better job of making sure that my threads are always fully used. I'm not just sitting there parked on the thread doing nothing, but not freeing up the thread for something else in the system to use. So because you have a single type and you have a single way of describing all sorts of data, right? I talked to you about streams of data. Well, the reactive streams APIs give you a way to describe small amounts of data. They give you a way to describe large amounts of data, slow data, really fast data, infinitely long streams of data, or infinitely small streams of data. It doesn't matter. It's the same type. And because of that, it doesn't matter if you're talking to Apache Kafka, which is an asynchronous kind of API where data comes in maybe at a trickle or maybe all at once or maybe in large amounts. But the point is it comes in perpetuity. Or if it doesn't matter if you're talking to a WebSocket endpoint or a REST endpoint or a gRPC endpoint or whatever, SQL database, a Mongo, a NoSQL data store, doesn't matter. You use the same exact type. And so much of the tedium of building microservices and building distributed systems these days is that integration code they have to write to adapt one stream of data's life cycle to another, right? So I want to get data from this Kafka queue, but I want to send that data out as WebSockets over here. Well, they're not the same API. They don't understand each other, right? So you have to line things up so that when a message arrives over here, that you send it out over here, right? With reactive streams, there's none of that. You just hand the reactive stream from here to the reactive stream over there. It's so much simpler. So you get one type, one abstraction. That means that your code becomes much simpler, right? And I could talk about reactive programming all day long and night too, because I love that stuff. But the point is, reactive programming gives you three benefits. One of which is resource efficiency. The other one is ease of composition. And the third of which is because you have a single abstraction, a single type, you have a natural place in which to interpose the operators that make working with distributed systems more robust, more resilient, more safe. Things like retries and circuit breakers and timeouts and also back pressure. Whenever you're building distributed systems, things will fail or they'll go faster or slower than the other side. So what happens when you as a consumer are being overwhelmed by a stream of data from the producer? Well, there's always the risk that you get overrun, you get denial of service in effect, right? You get overwhelmed and you can't continue processing the data. So there's a tedious state machine that all distributed systems and network protocol writers have to think about, right? What happens if one side goes faster than the other? Well, with reactive APIs, it's built in. There's a built-in way to say, hey, I can't handle any more data right now. So this makes your systems more robust. So back pressure, timeouts, retries, circuit breakers, because you've only got one thing, you've got one type called a reactive stream, then you can use these operators for all the different applications of that type. This makes your code more robust, less complicated, more consistent, and more scalable, right? So I love reactive programming. Wouldn't it be nice if there was a binary protocol, a network protocol, that at the protocol level reified the concepts of reactive programming? Well, that's exactly what RSocket is. RSocket was built by engineers at Facebook and Netflix. It's just a way for two different sides to communicate, but it understands at the network level this concept of back pressure, whereas things like HTTP do not, right? With HTTP, if I am a client and I connect to an HTTP server that's using reactive APIs, there's no way for me to disconnect, or to stop asking for data from the HTTP server, but still stay connected, right? If I don't want any more data, I have to disconnect. And so all the server can do is cancel the production of the data. It can't just pause. There's no way to do session resumption there. So there's some interesting implications for that. But RSocket is a very nice protocol. Let's go ahead and build a simple microservice to manage profile data associated with each customer. Okay, so I've got the customer profile here, microservice here. Let's do this one here quickly. Did it open? computer. New window. Thank you. Very polite. Okay. Profiles. Very good. So there's our profile service, and this is just going to be a very simple RSocket endpoint. We'll say RSocket server port is going to be 8181. And we're going to just create yet another controller here. I'm going to call this RSocket profile controller. Okay, and here, what I'm going to do is I'm going to have some data with some profiles in it for each customer that we have in the customers database. Okay, so we have 8 customers in the customers microservice. So therefore, each one's going to have a profile account, a profile associated with it as well. We don't need a real, actual microservice here. So let's just build something kind of in memory. So val ID, perhaps, and val customer ID, right? So good. There's this, and I'm going to build a val DB, and it'll be a map of. Okay, I'm going to say 1 to profile. Actually, what's a better way to do this? Let's just think about this. We want to one to 8. Okay, that's a range. Map that to, and what do I have for it? It is an integer, and so that's a profile. Okay, and I'm going to turn that into a ID. Into a private val ID equals atomic integer. Well, see, this is the kind of code that I would have written in Java, and this is very hard to translate in a nice functional expression like syntax that I was talking to you about earlier. So I get it. I understand why it can sometimes be hard, but it's okay. Okay, so ID, we're going to increment that each time, and then the ID is just there. So this is my profiles, and then what do I want to do? I want to convert that into a map, don't I? So how do I do that? To typed. I don't know. Is there a collection I can use? To a collection. Let's just see if I can get a Java 8 stream. There you go. To collectors dot to map. And what does this want from me? It wants me to give it, given a key, which in this case is going to be the profile. I'll say, given the profile, given it, I want given it. No, map. It wants a function. Okay. And it does it not have a to map? Yeah, I guess that's just okay. So that's fine. So we'll just create a constructor the old-fashioned way. Yo, thank you. So so we'll say db dot for each, and we want to do a concurrent map. So this would be profiles, and actually we can just keep that in here. It's cleaner. And then we want to have a db of record. So we'll say val db equals concurrent hash map of integer, just to keep it simple in a profile. And we're going to say for each profile, it's going to be profiles dot for each. This dot db dot id is it dot customer ID and it. Okay. Voila. Now, is that very functional? No, not at all. But it gets the job done, doesn't it? So that's at the end of the day, that all that matters. And again, it's very practical. I love this language. Okay, and actually, now that it's all here, we don't have any risk of it exceeding our, it's not going to execute on a separate thread. I'm happy just incrementing it, right? So very non-functional code, but hey, whatever. So ID plus equals to 1. There you go. So as a exercise. I should have refactored this, thought about this before, but it's okay. So we've got a bunch of profile data. Each record is indexed by its customer ID. I want to expose that data here using RSocket. So I use a RSocket controller. I'll say, given the profile ID, give me the right result back. So profile for customer, and I'll use the destination variable ID int equals this.db. And again, this is one of those nice things where Kotlin just makes life a little easier. I'm using a map here, but of course I don't have to use .get. I can just index into it like it's a first class type. So into ID, and voila. And so that'll return a profile, right? We can be a little explicit there, or will it? You can see it's not happy. It says, you're asking for a profile, and yet you're giving me a nullable profile. And so what I need to do is either do that, which is, oops, or just do that here, right? So that's, you can do the Elvis operator, right? You can say like, whatever, it's gonna be, if that value is null, then just return null. In which case the return value for this needs to be nullable, right? So there you go. There's the Elvis operator. Or just, yeah, it's useless in this case. It's just going to return null. Or just insist that it's not going to ever be null. And that's if you've ever yelled at your code, then you can appreciate how nice this is, right? You're literally just yelling at your code just to make it, just to trust you on this one. You got this, right? Okay, so there's my basic RSocket endpoint. Let's go ahead and restart this.
Sorry to interrupt.
Sure.
There's a question.
Yeah.
What is the difference between stream.map and the map without the stream in the Kotlin?
The map without the stream.
Yeah,
this one.
Yeah.
So this is a Kotlin function. I was going to use the Java 8 Streams API because that's my clutch here. I hadn't really thought about how I convert to a map. I don't know how to do that offhand. I'm sure it's trivial, but I was going to go for the Streams API. But then the way you would convert it into functions was just taking more than a few seconds longer than I wanted to spend. So I just wrote imperative style code instead of using the nice functional Java 8 Streams API or the Kotlin API. All I'm trying to do is to create a map of profiles to ints, but for the life of me, I don't know what it is as I stand here. So I decided to defer that until later. But these functions these are built into Kotlin. They're just there, whereas the Java 8 Streams API is only for Java. It comes from Java, right? So it's redundant in some cases. What is upset with this? Unresolved reference. Why is that true? Oh, right. Val p equals p. There you go. Okay. Or friends, or you could have just done that. That would have been cleaner. Okay. So I hope that answers your question.
And
so we have
another question.
Yes.
I'm sorry.
No problem.
There's one question, that is, what is this init method? Is it an extension function inside the controller?
This is just a function. This is a constructor in Kotlin. I mean, you've seen me use constructor parameters. There's a primary constructor which has this is a constructor that has access to all the things that you describe here. So if I say that this type requires a ID, well, I can read that field. It's not. There's no Spring Bean type named ID, but the point is I can say print line here, name or whatever, right? String. I can print line this dot name, right? That name comes from this constructor parameter. I can even do this even if it's not a field, if it's not storage, right? It's in scope. So it's like I'm inside of a constructor here. This name, this parameter here is only accessible within init. It's not visible anywhere else now because it's no longer being stored to a field, to storage in the class. You can also create secondary constructors, which they actually have the token constructor, the word constructor in them. But again, you almost never do constructors in Kotlin because it's so easy just to create expressions, right? Except for this. I just as soon as I said that, I ran into a situation where my brain froze. So I don't,
Yeah.
Take what I say with a grain of salt, I guess.
Yeah, got it.
Okay, so let's run this. It's up and running. you can talk to it through a lot of different approaches, like RSC. I don't even know if I have that, do I? Brew install RSC. Let's see if it's already there. Nope. So rsocket RSC brew. There's a tap I need, I'm sure. Voila. Okay. So, no, okay. Well, whatever. Okay, so point is you can talk to it from RSC, but we're going to talk to it from our Reactive API. And what we're going to do is we're going to go ahead and create an edge service. And this edge service is going to be a service that talks to our downstream APIs and that lives at the logical edge of the architecture. So I've got an RSocket-based microservice over here, and I've got an HTTP customer service over there. They're two different protocols. They're two different microservices. And if I want to introduce, if I want my clients, and by which I mean my iPhones, my Android devices, my PlayStations, my Xboxes, my tablets, my phones, my TVs, my cars, all these different, my watches, my goodness, everything has a client SDK these days. If I want those things to talk to these various microservices, should I introduce redundant security and routing and compression and load balancing for each one of these microservices? Or would it not be better to funnel those client requests through a common layer where they can ensure a consistent level of quality, right? A consistent quality of service for things like routing and security. So that's what an edge service is. It's a go-between the outside world and your downstream microservices. And it's a natural place in which to interpose generic cross-cutting kinds of concerns, things like I say, security, authentication, token inception. And so there's a lot of things you might do here at the edge. One is an API adapter, wherein you take data from these different microservices and reshape them in some way. Maybe you have a client that has low bandwidth, or it's roaming, or it's bandwidth constrained, or maybe just wants the data in a particular shape, and it's too burdensome to ask the client with its minimal bandwidth availability to call these different microservices by itself. So in the edge, you might just create a view of the data that the client can use to more efficiently render the screen in Android or iOS. So those are API adapters, very common. You might create API gateways. These are basically proxies that add to the request and to the response in some way, but typically generic, sort of agnostic to or ignorant of the particulars of the payload being conducted across the wire. And you can also create data integration code, right? Data integration logic using something like GraphQL. So let's take a look at some of those possibilities here. We're going to create a third microservice, like I say, called Edge, and this will be a go-between, a intermediary between the outside world and our downstream microservices. So in order to use this, we'll look at Spring Cloud Gateway. When you look at the reactive web support, which is a non-blocking HTTP client, and we use the RSocket support. Okay, so very good. Kotlin all the way, of course, hit generate. And we're going to open this up as we did before in our IDE. Now here we have some interesting opportunities, right? The first thing I want to do is I want to build a Spring Cloud Gateway application. Well, remember I told you earlier that Spring Cloud Gateway, that the Spring ecosystem really embraced the Kotlin language. And one of the first places where we saw that is in Spring Cloud Gateway, which has a lovely DSL for Kotlin. Okay, so we're going to use this here. We're going to create a bean. And actually, even before we get started with the gateway, we can actually just talk about Spring. All this time, I've been showing you typical Spring dependency injection and configuration in terms of the Java style, right? So here's my Spring Cloud Gateway bean. I'm going to create a function. That's this function here. You can see this function. Let me just let me create something here. There you go. There's this is a typical Java Spring Bean definition. Yeah. So it's a function with the bean annotation with a name. The name of the bean is called gateway. It has a dependency. In this case, a bean of type route locator builder needs to be injected as a parameter to this function. And by virtue of that route locator builder, this function is able to build an object for us, which the Spring framework will manage in the context of type route locator. So this is pretty trivial. If you've ever used Spring, you've probably seen this basic dependency injection. But even this has a DSL, right? In Kotlin, that's even better. So I can create a context here, a Spring Bean context, and each bean is just a function invocation. So I'm using functional registration. So I want to redefine, instead of having a method which has to be described in terms of a reflection, the Spring Bean, the Spring application will start up and it'll discover all these methods that have @bean on them. Instead of doing that, I'm going to use this functional API. So I'll say add initializers, context, and then I'm going to create bean of type. I'm going to need to look up a bean of type route locator builder. So I'll say RLB equals ref. And again, I don't have to use a type token here because there's a nice static DSL that reifies the generic type. So I'm saying this is the generic type for this call site for the invocation of that function. But because of Kotlin's pseudo reified generics, where it basically copies and pastes this type as a type token at the call site, because of that, it looks like it has true generics, right? So I can say, okay, given that we have a route locator builder, I want to return a Spring Cloud Gateway route locator object. And here, instead of using the API that I hinted to up there, I can use the Kotlin DSL. Look at that, dot routes, very different from this, right? In order to use this, you have to chain things together. So you create a route and another route and so on, right? And there's some work that you have to do in here. Instead of doing all of that, what we're going to do is we're just going to say dot routes, and I'll define yet another route therein. And in a given route, you define how requests coming into this edge service, in this case running on port 9999, server port 9999, how routes coming into that port and that host get matched. So if a request has a proxy path, /proxy, and the host is equal to wildcard.spring.io, if that's all true, then I want to send it onward to localhost 8080/customers. Well, okay, already we have an opportunity for cleaning up the code, one of which is infix notation function invocation, right? So we have a DSL. I can drop the dots in between, and it's exactly the same. Now, we're looking at this code here, and you can see that there's no call to .build. I don't need it. It's just implied because I've got this very nice clean DSL here. And in fact, I've got this intermediate variable, but what did we talk about? We don't need intermediate variables. Whenever possible, it's just fine to just chain things together as an expression. Even so, now let's returning to Spring Cloud Gateway code here. This isn't going to work, is it? It's going to match the incoming request that says /proxy, and it's going to send that request otherwise unadulterated to the downstream service, in this case, /customers, /proxy, which doesn't exist. So we need to change the incoming request using a filter. And again, we have a nice DSL for that. So I'm going to say set path is customers. And that means that down here, when I specify that, that's redundant. So see that? I've got a DSL to match the predicates, to describe the predicates. Then I have 0 or more filters, and you can do all sorts of things. So you can say add response header. Maybe I want to add cores support, access control, allow origin. Let's see here. Fine, right? Maybe I want to do a rate limiter. There's all sorts of things you can do here, but the point is I'm happy with what I got. And then once that's done, once my filters are done acting on the request, they'll send the request onwards to the downstream service, and then we'll get the response. Those will go through the filters again, and then back to the client. Okay, so isn't that nice? That's a functional DSL, and it almost looks like a config file, right? As opposed to programming. So that goes away, and now you've got this nice functional style of defining your beans in Spring Cloud. In Spring, and just in Spring Boot. Let's go ahead and start this and see what it looks like. See what it gives us. See what it does. Okay, good stuff. So let's see. Okay, so curl. This is not going to work, right? We know it's not going to work. So localhost 9999/proxy, right? Why is it not going to work? Because there's no host header. So let's take a look at that. See, it says 404 not found. So we need to say -host is hi.spring.io. And there we go. You can see the data comes back as you'd expect it to, right? So there's the JSON We got the access control origin header. So good. That's an API gateway. Very simple. Oh, Netty is having a native library that it's looking for. Thanks a lot for that useless error. Okay, so now we have a very simple example, but it does demonstrate that, this is a Spring Cloud project, and it's got this very nice Kotlin DSL, and it almost looks, I can kind of recognize it, but it looks almost nothing like the actual Java API that you can substitute it for, right? It's just a very nice way to work with Spring Cloud Gateway, and it's in addition to the Java API. I love this. Okay, so we've got a very simple API gateway. Now, what about API adapters, right? API adapters are basically you take the data from different sources and streams and enrich them or transform them or compose them in some way, right? And this is the wheelhouse of reactive programming. It makes it trivial for me to express concurrency, and which you want when you're doing service orchestration, right? You're doing service orchestration and composition, scatter, gather style service orchestration composition. But, it's still a different way of writing code compared to just standard imperative IO. So wouldn't it be nice if there's some way I could write asynchronous, non-blocking, very scalable, very performant code without having to write too much code in terms of that API? Well, it turns out Kotlin has a very nice feature that supports that called coroutines. So let's go ahead and write a very simple client to talk to our downstream service. We're going to call this customer, we're going to call it CRM client. And in order to do our work, we're going to need a pointer to the reactive non-blocking HTTP client and to the reactive non-blocking RSocket client. Okay. And for that to work, we're going to need to actually define those objects, aren't we? So let's go here. We're going to say bean. And the first bean that we want is we need to say it RSocket requester.builder. Bean, what are we doing? We're looking at, ref. Yeah, ref dot. And so we're going to inject a RSocket requester.builder, and then we're going to say TCP. So that the RSocket service lives in localhost 8181, and that gives me a pointer to the RSocket requester, right? If I look at that, RSR, and that actually is the thing that we want in our code downstairs, right? So this code right here needs an RSocket requester, and you can see the pattern is simple. I inject a builder, I use the fluid DSL to get the thing I want, and then I get a reference to the thing I want back. Okay, so no big deal. That's exactly the same approach that we're going to take for the non-blocking HTTP client. We're going to say exactly the same thing. So web client dot builder, hello, okay, ref rather dot build. Okay, good. So I've got both my non-blocking HTTP client. This returns a web client, and this returns an RSocket requester. I'm going to use those here. So fun. Let's think about this. We want to get. We can write this. Let's just write this. We'll write the first bits in Reactive APIs, and then we'll do the orchestration using coroutines. Okay, so we're going to say customers. This dot HTTP dot get dot URI localhost. I'm calling the downstream microservice containing the customer data, and when the data comes back, I'm just going to churn the data using a nice reified generic extension function here that comes back from the stream for the JSON data. I'm going to churn that into this data type representing the JSON structure that comes back in my data. Okay. Very simple. So I'm using a data type there. What about the order data? Sorry, the profile data. Well, okay, fun profile for customer ID. Okay, and I'll say this dot RSocket requester dot route profiles dot CID, and I'll say when that data comes back, I want to get the data as a single value. And again, we can use the reified generics and an extension function. Okay, so what I have now are a reactive type of called a mono, which is a reactive type, like a completable future, if you will. And here I have a reactive type called a flux, okay, of customer. So these are both reactive types. Now, the thing is, if I know how to use these are fine, right? They're not all that hard. Oh, I need to create a data type for profile, don't I? So data type profile val ID int val customer ID int. Okay, so let's go ahead and remove the extra Spring Framework profile annotation. Okay, so I know how to use these reactive types, but I suspect a lot of people won't. So let's use coroutines instead. In order for us to do that, we need to make sure that they participate in a coroutine context, and we need to tell the compiler that these expect a coroutine context, right? So that if they ever get started outside of one, we get a nice little compiler error saying we've done the wrong thing. So this is going to be it's a 0 to n value thing, right? So there's more than one value. So we're going to return a coroutine flow, which actually feels, it's not really like an improvement over a flux in this case, but it'll work, right? So we want as flow? Yeah, flow, okay? That's fine. So we got a flow of customers. Now what about this? I want to turn this into just a profile. Okay, well, the way I do that is I await the first value. So what we're doing is we're saying, when you get to the await function, behind the scenes, we're going to send some requests to a socket, and that socket might not respond to us anytime soon. And so this is one of those examples where I don't want my code to sit on that thread waiting for the response from that socket, which might be here in the next nanosecond, or it might be here 100 years from now, right? Once we send those bytes out with a request, we just don't know when we're going to get a response, right? And so rather than sitting on that thread, which can be an eternity, especially in terms of CPU cycle time, rather than sitting on that thread doing nothing, we register a callback and we immediately jump off, right? And when we write these reactive calls using reactive streams, we're saying invoke me when the callback is done. When the callback has been invoked, invoke my reactive code, and the data will flow from one step to the next and continue where it left off. But that means you get this like callback centric code if you're using JavaScript circa 2010, or at the very least, you get this method chaining that looks like JavaScript promises, right? So if you want to avoid that, then you need to involve the compiler. And that's what we're doing here with coroutines. The compiler knows that you've got a suspending function. Await first is a suspending function. It knows that it will do something asynchronous, during which time the compiler should pause the function, register a callback, and then relinquish the thread back into the thread pool. So it's going to do that work of waiting for the response and then involving our code by resuming the function, the execution for us. But we don't have to write code for callbacks and all that stuff ourselves. That's all done in the compiler itself. So the result is that I can say that this function returns a profile, and it does. It's just that if you were to actually put a breakpoint, you might find that the first part of the function, before we do the await, executes on a separate thread from the parts after the await, right? Because they might actually be, there's compiler chicanery happening behind the scenes there. Okay, so that's great, right? I've written this very sort of simple code. The result is that my client doesn't need to care whether that there's reactive APIs behind the scenes. They just know that they have a flow of types, which is like a collection, and they have the profile. Now, what I want to do is I want to compose this data from both the customer data and the profile service into one view. So I'm going to create a new DTO. I'll say data class customer profile val customer val profile. Okay. And this is just a composite view of both types of data. So I'll say suspend fun customer profiles. And I'll say this dot customers dot map, right? Dot map. And when I have it, I have the customer. So I want to then, let's just be explicit here. It's always good to be explicit when you have more than one line of code. I'm going to then get the profile. So I'll say val profile, this dot profile for customer.id. Okay, so now I just do this. I just say customer profile, customer profile. There you go. That's it. This looks like it's just going to be standard, sequential imperative logic, but it's not. It happens on many different threads. Each time I call the profile service and I use this await thing, I'm actually on a separate thread in theory, right? I could end up in a separate thread in a separate thread pool. And if I have 100 customers, this is actually the worst case scenario, and it's still this nice because in this case I have the worst possible outcome, which is n+1. I've got all the customers, and then for each customer, I have to go get the profile. But at least because it's using coroutines, it's doing it concurrently. It's using reactive APIs, which in turn, because of these extension functions in the reactive APIs in Spring, we have these extension functions that automatically turn them into coroutines for us. So we can get the best of both worlds here. We get reactive, non-blocking code, most efficient version of the code possible, while also getting this very nice sort of imperative style code. The look of the code, the aesthetic, the style of it, it feels like it's imperative. I'm holding a profile here at this line. I'm completely oblivious to the fact that this behind the scenes actually paused a thread and went off and did some network IO and came back some unknown time later with the bytes and only then invoked or revived another thread. So to prove that, let's just go ahead and create yet another controller here. Okay, I'm going to say class CRM REST controller, private val CRM client, at response body, fun customer orders, this.crm customer profiles. Okay, we want that, and so this is actually another suspending function. Remember, I'm calling a suspending function, so I have to propagate the context all the way through. Okay, but Spring doesn't care. It doesn't, you can use the component model, CP, customer profiles. You can use the Spring controller component model just like you would without coroutines. All you gotta do is make your function suspend, and Spring will make sure that there's a context that gets created for you, to a coroutine context when you run your application. Very cool. So localhost 9999/CPs. Whoops, something went wrong. Failed to convert Java lang string. Oh, custom. Okay, my RSocket service is unhappy. CI profiles. Oh no, it's got to be something else. Okay, so let's see. Profiles.cid. Oh, I didn't provide the ID. Right, I didn't pass this in. Yeah, okay. So we can restart that. Oh, don't you hate having to restart? Okay, well, that wasn't so bad. There we go. So I've got the customer data and the profile data that are both coming from different microservices, and yet I don't have to worry about it, right? It's the simplest possible version of the code. It's concurrent, scatter, gather, service orchestration, and composition. But because of the joy of reactive programming, because of the joy of coroutines, it's as simple as it could be to read and write and understand, as well as to scale. Okay, any questions on that before I move into our last little thing here?
Yeah.
Yeah.
So, Josh, there are some certain questions about reactive style of programming. Like, for example, if we use the reactive style, it is something like it is always, for example, there are 1 lakh records, and it is taking the record, querying the database, and it will keep on pushing to some downstream. It could be UI or something. So if UI or downstream may not be able to have equipped enough to capture all this data the same way how producer is producing. So how, in that scenario, how we can have limitations on the data?
So you're saying if you've got a reactive stream, you want to know how the client, like a UI or something, could push back?
Yes, I mean how it can take and process it. The reactive style is something like it won't stop, right, until the data ends, stream ends.
No. It's quite the contrary. Okay. When you get a Java collection, a Java util collection, you don't know how much data you have, right? By the time you have a reference to a Java collection, let's say that you have a function or a method, you call the method and it hands you back a Java collection. By the time you're holding a reference to that Java collection, you might be holding millions of values and you're just about to run out of memory, or you might have 2 values. You just don't know until the time that you've got it, right? By the time you can ask collection.size, it's already too late. You might already have too much data and you're about to run out of memory, right? You just don't know. With reactive streams, you're given a thing that says, this is good, it's a redeemable for data that's going to come in the future. But you, dear consumer, are in charge of asking for that data. So you pull the data from the reactive stream. Instead of having it all pushed on you or forced upon you, you are able to pull 10 records at a time, for example. And what that means in concrete terms is you have this base type called publisher, right, from the reactive stream specification here. And so this base type has a publisher. It's a thing that publishes data to a subscriber. When the subscriber first subscribes, it's given a subscription. We're going to come back to that in just a second. When new records arrive, they are communicated here in the onNext method. When there are errors, that's communicated here in the onError method. And when there is no more to be done, that's communicated here with the onComplete method. So let's talk about this onSubscribe. OnSubscribe is where you get a subscription. So the subscriber to the publisher, when it first subscribes to that publisher, is handed a reference to a subscription, which the subscriber can then use to request more records. So no data happens, nothing happens from the publisher until the subscriber asks for it. You want the first record, you have to request 1 record. If you want 10 records at a time, you can say request 10. If you want a trillion, you can put in 1 trillion records. It's completely up to you, but the subscriber is in control of the rate at which they consume that data. And it's this ability to drive the speed, the cadence at which you process that data, that gives you the ability to be resistant to overwhelming amounts of data. Because the only person that controls how much you consume is you, right? You can't be surprised. You can't be overwhelmed. You're the one who asked for 1,000 records. You got 1,000 records. Now, there's no prescription here as to how quickly you might get that 1,000 records. It might be you get 1 record every year for the next 1,000 years, or you might get all 1,000 records in the next nanosecond. So it's up to you to specify how much you feel like you can handle in one fell swoop, were it all to be delivered instantaneously or whatever, right? So this is behind the scenes. You don't normally have to deal with this mechanism here, but even if you're using the higher, more specialized abstractions, the flux and the mono that you saw earlier, retrieve mono and body to flux, even if you're using those higher, more specialized abstractions, those implementations of publisher, behind the scenes, that back pressure is in play. Does that make sense?
Yeah.
And that's how, because it's core to reactive streams, everything you do with reactive streams benefits from that back pressure mechanism. Okay. And it makes sense. It makes sense at a macro level, right? We build microservice A and microservice B. We use a message broker to absorb excess demand, and the consumer, pops a message off of the queue 1 at a time or 10 at a time or whatever in batches until it can finish everything in the queue. It drains the queue, but the queue doesn't push data onto the consumer. The consumer pulls the data out of the queue. That's the same thing we're doing here in the Java protocol level, Java API protocol level.
Okay, Josh, there is another question.
Yes, sir.
You used coroutines, and you also used something like flow. So
yeah,
when we are using coroutines, for example, we have 10 threads are there for our application. Is the coroutines are going to use all the 10 threads?
Say that again. You have what in your application?
For example, we have 10 threads are scheduled in our application.
Okay. Yeah.
There is a thread limit. So
sure.
How coroutines are they going to use all the threads in the application?
No, there's usually a thread pool, right? I don't know how you specify it for the Kotlin.
Yeah,
so there's a thread pool. There's a thread pool for Reactor, for example, Project Reactor, which is the reactive data flow library that we're using behind the scenes here. It has a thread pool. All the reactive code that you're seeing here executes on what's called a scheduler, which is basically the Reactor concept of a thread pool. And that thread pool by default is 1 thread per core. So if you have 4 cores, then you have 4 threads, and that's it. Because again, as long as you're never sitting on the thread, just wasting time, just checking the weather, as long as you're not doing that, then there's no reason to have more than 1 thread per core. And the reason you have more than 1 thread, and the reason if you have 4 cores, then it makes sense to have one thread per core. But that should be enough. That's more than enough usually. If you have something that's blocking, something that does like a calculation, like the Fibonacci series or cryptography or Java IO input stream, all the stuff blocks, and that makes sense. And if that happens, then you need a different scheduler. But by default, it's just 1 thread per core. Does that make sense? And but it's gonna fully utilize those. That's the point, right? Is you'll never if you log in and you look at your memory and your activity in the server, you'll never just see threads sitting around in a wait state idle, right? That's the goal, is to constantly keep them moving. You want 100% utilization of your CPU, which you can't get if you're using synchronous blocking IO.
Okay, makes sense, Josh. Yeah, Josh. Also, there is only 15 minutes of time we are left with. Yeah.
No problem. I will be wrapping up very shortly. I think I have just one more little party trick I wanted to show you.
Yep. Please.
Oh, okay. So we've got our we've looked at service orchestration and composition. We use reactive APIs and coroutines and all that good stuff. We looked at what's the issue with this? Oh, it seems to be unhappy about something. Oh, it's the auto wiring. I just disabled this. Why is this? Okay, I'll set that up later. Okay, so we've got service orchestration and composition. We looked at coroutines. We looked at Spring Cloud Gateway and the custom DSL that you get to take advantage of. Is just one of the many examples in the Spring ecosystem that includes Spring Security, Spring Data, I think Spring Integration for sure. Spring Framework itself, and so on. There's a lot of different DSLs all throughout the ecosystem that take advantage of Kotlin. So we looked at that. We also looked at the DSL for Spring Framework itself, the Beans configuration DSL that, behind the scenes, this is using functional configuration. There is such a thing as functional configuration in the Java world, right? In the Java syntax experience of Spring, but it looks very different from this because it's much more verbose, because it's necessarily more verbose. In Kotlin, it's just gorgeous, very, very svelte. So we looked at all that. And we're talking about, this is our little tour of edge services, and we're looking at different things you can put at the edge. And I mentioned the idea, or I alluded to the possibility of data integration layers. An integration layer is a thing that it just integrates, right? It takes your different streams of data and pulls them together into one coherent whole. And the reason you might want to do this is because, you work hard to create microservices which are standalone, self-contained, independent things, their own bounded contexts, etc. And the reason you need to do that is because you want your teams to be able to break down into small groups. And the smaller the groups of people, the faster that group can iterate, the less time they spend stabilizing, synchronizing, integrating their code, the better, right? So we like small groups. That's why people move to microservices. But when we build our client, when we build our iPhone experience and our our TV experience and our browser-based experience, whatever, we don't want to have to call 10 different services. We want one service that we can call, not least of which is because it's just logistically more painful to do otherwise, but also because it's more efficient, right? Instead of doing all the service orchestration in the Android code where my battery might be low and I have very little bandwidth and all that stuff, I want to do it on the server side where I'm in the same data center and I have presumably, a fiber or something like that between services. So I want to do all that. I want to have a cohesive view of the system, a coherent view of the system, and I want all my data co-located together. And yet, as an architect, I want my services to not be co-located. I want them to be separate so I can have small teams. So there's a conflict. And Facebook had this exact same conflict back in Meta. They had the same conflict back in 2012, where they decided that they needed some way to make it easy for the client to get the data that it needs from across the different, topology of services, but they don't want to compromise on the ability of those different services to be independent. And so they created something called GraphQL. Now, GraphQL it's neat. Like I said, 2012, it's almost 10 years old now. They open sourced GraphQL in 2015, and you can use GraphQL today. There's a project we have called Spring GraphQL, which is not yet GA, and it in turn builds on the GraphQL Java project. It's the spiritual successor to this GraphQL Java Spring integration. And we worked closely with the GraphQL Java team to build it. Because it's not yet GA, it's not yet on the Spring initializer. So I can't just go to start.spring now and add the checkbox. But I do need to get the RC1. I'm going to check RC1 here. I'm going to hit Explore, and that'll allow me to get the Spring milestone repositories. So plugin repositories. Okay, take that. And I need the repositories for the dependencies as well. Okay, and with that done, I can manually add the GraphQL Spring Boot starter. So GraphQL Spring Boot starter, and this is org Spring Framework experimental, and I want the version to be oh gosh, what is it? When in doubt, cheat. So github.com, Kubernetes native Java. I've forgotten this particular dependency. There you go. Let's just copy the whole thing. Very good. Maven. Okay, to the right. So it's going to download that dependency. Very good. So now it's there. And GraphQL is a typed schema-centric way to build services. So for example, here's the SpaceX API. SpaceX is a, aerospace venture by Tesla motor vehicle founder Elon Musk, and it's whatever. But the point is they have a GraphQL API. And so this API is a good place for us to kind of to meet GraphQL. In GraphQL, you have a bunch of queries, that is to say, ways to read data. You've got mutations, which are ways to update data, and subscriptions, which are ways to read data, but over a long period of time. So, think stock feed data or sensor data or whatever. And that's it. You've got subscriptions, mutations, and queries. Functionally, that's all you need to know. That for 99% of the cases, that's your experience of GraphQL. And this is great because it simplifies everything. If I want to read data, I create a query. If I want to update it, I use a mutation. There's no argument about whether the mutation is using post or put. There's no discussion around should I use 201 or 202 or 200. There's no like Rastafarian dogma that you have to fight with to make sure it's RESTful or whatever. Or using hypermedia or not. I mean, none of that. It's just you use a mutation. And yes, it is using HTTP, incidentally, but it doesn't need to. You can actually run GraphQL on top of WebSockets. And personally, I would love to see support for running it on top of RSocket as well. Okay, so we've got let's say I want to call one of these endpoints, one of these queries. I hit Control Space. It says, okay, you've got the user's endpoint, the field. What data do you want from that? Well, I want the ID. What if I also want the name? Okay, just hit name, right? So this gives you that. Okay, what about the rocket? Well, the rocket is a complex object that has subordinate fields, isn't it? I guess not, it doesn't. So there you go. What about that? What about Twitter? Right, so I can, all that kind of stuff is there as well. So you've got these fields, and what if I want the company information? Okay, given the CEO, great. What if I want the employees? Whatever. You see the point? I did by changing the shape of the query, I changed the shape of the data. So instead of me constantly having to create new edge services with new API adapters, I can deploy one GraphQL endpoint. And if somebody needs a lot of data for a richer experience that takes a whole screen and drives a lot of different user experience interactions in one go, great. But if I'm also building a client for my Apple Watch or whatever, and it's just, I just need one little crawl of text, then that's fine as well. I can use the same GraphQL endpoint. I don't have to constantly build new edge services. So let's do that for ours. We've got our service. We need to create some schema because, again, it's typed, it's discoverable, it's introspectable. And the way that works is you create a directory here called GraphQL. And then I'm going to create a new file here called schema.graphqls. In that file, I'm going to create some types. And so the root type of all GraphQL queries is a type called, guess what? Query, okay? And these are just objects, basically. They're class definitions, if you will. So my root query is going to have a field that gives me access to all the customer records. Well, I need to define what a customer looks like. So I create another type here. It's going to be called ID, and it'll have a name field as we do in ours. And I want my customer data to, in turn, have access to its profile. Well, keep in mind that that profile data comes from another microservice. But if I want it, I want it, right? So I'm going to make it so that I can ask for it if I want it. And if I don't ask for it, then I don't pay the penalty of having to invoke the profile service. There's no call to the RSocket service ever made if I don't ever ask for that data. So let me create this here. And what else do I want? I want the customer ID, right? So there's my two fields. So it's a customer, it has a profile. They're both fields, and the query has it returns a field of customer. So the brackets mean 0 to n. You know, it's more than one. If you don't see the brackets, that means just 1 or 0. Okay, so let's now implement this type, this little structure. In order to do that, I'm going to use Spring GraphQL to create yet another controller, right? I've got a REST controller down here. And maybe you've seen a theme emerging tonight or this afternoon. A controller annotation in Spring is not tied to HTTP or to RSocket or to GraphQL or to anything. It's always just been about taking requests from a protocol and adapting it and connecting it to your business logic to produce a response, which gets sent back out over that same protocol. Okay, so let's create a controller, CRM GraphQL controller. And just as before, we'll use the CRM client that we just so painstakingly built. And we have to satisfy, we have to resolve when somebody makes a request to the query type asking for this field, we need to resolve the response, which is a collection of customers. And so you use schema mapping. You say type name is equal to query, and the field name is equal to customers. When that happens, then I want to resolve it by letting them invoke this map, this controller handler method called customers. And I'll just return that. Okay, so this is also a suspend function. Right, there we go. Well, what if they want the profile data? Well, again, you create a schema mapping. Type name equals customer. Field equals to profile. And I'll say profile. Now, of course, in order to figure out the profile for a given customer, I need to have access to the customer itself. After all, how do I know which ID to send to the profile service if I don't know which customer I'm talking about? So I'm going to inject the customer object here as the root. I'll say this.crm.profile for customer.id. Okay, and again, this is a suspend function. So I'm just returning, just so we're clear, I'm still just returning profile types. I'm using coroutines still, right? Now, this schema mapping makes perfect sense for this custom type that is unique to our business logic. But remember what I said, query, that's the root of all GraphQL types. It's very, it's going to be redundant a lot of times. So Spring GraphQL provides some convenience annotations instead. You can use @query mapping. Behind the scenes, this is equivalent to a schema mapping where the type name is equal to query. And it turns out you don't actually have to specify the field here. That's redundant. You can just derive it from the name of the method or the function in this case. And that's what we're doing here. So it's query mapping. So that means that it's equivalent to that. And then because it's named customer, that's equivalent to this. Okay. So isn't that nice? Look at that. Very, very clean. Let's go ahead and restart this one more time. Hopefully I've lined everything up so it should work. Nope, I forgot to shut down the existing one. Fantastic. So localhost 9999/graph IQL. That's the name of the console that they used in SpaceX. Okay, so now query customers. Good. There's my customer IDs. Name. Now, what if I want the profile data? Okay, I can ask for it, and it'll make a call to the network service. And again, it's doing service orchestration composition. It's calling a coroutine, and that in turn is doing asynchronous concurrent calls. So even though I'm calling, like if you put a thread.sleep for each call on the profile, because they're non-blocking, you wouldn't wait for 8 seconds. If you said thread.sleep for 1 second, you would just wait for 1 second. It would do all 8 at the same time. So, but if I ask for the profile data, I get the profile data. If I don't ask for it, there's no call made to the profile service. So this is the best of both worlds. Graphql gives you a way to create one coherent view of the data that uses coroutines and is an ideal way to glue together disparate services. The client that consumes this GraphQL endpoint has no idea that it's talking to one HTTP service and to another RSocket service. It doesn't need to know, doesn't care. If you ever decide to change the backend implementation, it won't know either, because you've just got this type system that that's been surfaced. My friends, this was fun. I hope you got something out of it. We looked at just a bunch of stuff that I think, taken together, show that Spring, powerful, very productive way to build modern services, but Kotlin and Spring is really something else. That's something special. We looked at a lot of different things, small things. Like I said, it's a winning through 1,000 extra little wins, instead of 1,000 cuts. I want to thank you so much for your time today. Like I said earlier, as I started this discussion with you all, I wish we could be there in person, but the world is weird right now. I hope you're all healthy, happy, and safe. And I am very happy to take any questions right now. Thank you so much for your time.
Josh, am I audible?
Hi. Can you hear me?
Yeah. Sorry, I was talking in mute. Okay.
No.
Yeah. So you have shown GraphQL example at the end, right? It is really very nice to have it. But
Thanks.
I just have a question. Is the GraphQL, I mean, it can be a traditional question, but is the GraphQL is going to replace the REST services? Sorry, Josh, you are in mute.
Sorry, I just have to put my table down and it makes noise. I don't think it'll replace REST, but HTTP is interesting, right? HTTP is very useful, and so if you like building HTTP REST services, that's fine. Although I do like what I did today was HTTP APIs. I wouldn't call it REST, right? I didn't use hypermedia. I didn't use hypermedia as the engine of application state. Spring HotOS, right? Without hypermedia URIs, it's not really REST. And if you don't believe me, just ask Dr. Roy Fielding, the guy who created REST as a constraint on HTTP. And so a lot of people do what I just did, and they call it REST. I created some controllers where I returned an object, and they got turned into JSON. There's no hypermedia there. It's not REST. Simple as that. So I don't know. Will GraphQL replace REST? Probably not, but I hope it replaces a lot of this other stuff that we're calling REST, which isn't REST, right? What I just did is not REST. If GraphQL replaces that, that's great. That'd be nice. But if you're doing proper REST with hypermedia and links and all that, there's some really big benefits to that. Really big, nice benefits to a properly hypermedia-centric system.
That's good, Josh. Apart from that, from the comments, I see Vivek and Sayed, they are trying to say hello to you. Of course,
hello.
We are not offline, so from the comments and only we can say this. Yeah,
I appreciate it.
Yeah,
I appreciate everybody coming here. I appreciate your time. I hope you got something out of it. Say hi on Twitter. I'm at Starbucks Man. Just very happy to connect there.
Okay. Yeah. With this, we'll end. Let us wrap up today's session, and I really appreciate Josh time to have a wonderful presentation here, and
My pleasure.
Myself, I learned many things.
Oh, good. Okay.
Yeah. So, yeah, guys, if you want to give any presentation in the upcoming meetups, just feel free to contact us. Our mailing details, everything are there on meetup page, and we'll also update the description with the appropriate links. That's it for today. Thank you, guys. Bye-bye.